in the silent, unfeeling dark between the constellations, where the light of our own galaxy fades to a faint, ethereal dust, the universe unfolds on scales that defy the architecture of the human mind. It is a tapestry woven from gravity and time, stitched with the fire of 1,000,000,000,000 suns and embroidered with the velvet of endless vacuum. Here, in this cosmic ocean, swim leviathans of unimaginable proportion. They are not creatures of flesh and bone, but islands of light, cities of stars, entire clusters of galaxies bound together by the invisible chains of their own colossal mass. They drift through the eons, consuming, merging, and growing in a slow, majestic dance of creation and destruction. One such behemoth, a gravitational titan ruling its domain some 27 billion light-years from Earth, is known to us as Abell 2261. It is a kingdom of staggering wealth, home to hundreds of galaxies, each a jewel of stellar fire. And at the heart of this sprawling empire, there should sit a king. A ruler of impossible density and power, a supermassive black hole of such terrifying proportions that it would anchor the entire system. At the center of the brightest, largest galaxy in the cluster, a galaxy known simply as A2261 BCG, we expected to find this monarch, a gravitational heart beating in the dark. We aimed our most powerful eyes at the throne room, expecting to witness the furious light of a feeding monster or, at the very least, the dense huddle of stars held captive by its presence. But what we found was a void. An unnerving, inexplicable emptiness. The throne was vacant. The king was gone. This is the story of a cosmic mystery, a search for a phantom of unimaginable mass, and a profound question that echoes through the halls of astrophysics: how do you lose a supermassive black hole? Join us, as we journey into the heart of a giant, to confront an absence that speaks louder than any discovery. Now, let's begin. The kingdom of Abell 2261 is a place of extremes. It is an ancient and crowded metropolis, a region of space where the density of matter warps the very fabric of space-time into a gravitational lens, bending and magnifying the light of even more distant objects behind it. This is not a quiet stellar suburb, it is a chaotic, violent city center where galaxies are not distant islands but neighbors in a constant, gravitational struggle. For billions of years, this cosmic crucible has been the site of countless mergers, acts of galactic cannibalism where larger structures consume the smaller, their stars and gas swirling together into a new, more massive whole. At the center of this maelstrom lies the victor, the ultimate product of this relentless consumption, the brightest cluster galaxy, A2261 BCG. This galaxy is a monster, one of the most massive known. It is not a graceful spiral like our Milky Way, but a bloated, diffuse elliptical galaxy, a sprawling sphere of ancient, yellowed stars. Its form is a testament to its violent history, bearing the scars of every galaxy it has devoured. It is less a single, coherent entity and more a monument built from the wreckage of 100 others, a gravitational emperor reigning from the deepest point in the cluster's potential well. Within such a titan, the laws of galactic evolution dictate a simple, unwavering rule: at its heart must lie an equally titanic supermassive black hole. This is not a matter of conjecture, but of fundamental cosmic mechanics. The growth of a galaxy's central bulge and the growth of its central black hole are intrinsically linked, a symbiotic relationship written into the cosmos. The mass of the stars in the bulge predicts the mass of the black hole with astonishing accuracy. For a galaxy as incomprehensibly vast as A2261 BCG, the calculations pointed to a central object of truly terrifying scale, a black hole not of millions, but of billions, perhaps even tens of billions, of times the mass of our Sun. It should have been a cosmic anchor, a singularity so powerful its influence would be undeniable. A supermassive black hole is the heart of its host galaxy. It is the silent conductor of an orbital orchestra, the engine that can both trigger furious bursts of star formation and quench them with overwhelming outpourings of energy. Its presence is the defining feature of a galactic core. Around such an object, stars are whipped into a frenzy, their orbits tightening as they approach the point of no return. This creates a signature we can see from billions of light-years away, a bright, sharp cusp of starlight, a beacon that screams of the immense gravitational power hidden within. Furthermore, a black hole of this magnitude is rarely quiet. The core of a brightest cluster galaxy is a chaotic buffet of interstellar gas, dust, and shredded stars, all slowly spiraling inward. As this material falls toward the event horizon, it is accelerated to near the speed of light, compressed, and superheated to millions of degrees, forming a brilliant, churning accretion disk. This disk would blaze across the electromagnetic spectrum, a lighthouse of X-rays and radio waves visible to our most sensitive instruments. For A2261 BCG, the predicted signature was that of a quasar, or at the very least, an intensely active galactic nucleus. It should have been one of the brightest objects in its local universe, a beacon of gravitational authority. Yet, when we looked, there was no beacon. There was no bright cusp of stars huddled in fear and reverence around their master. There was no searing light from a final, tortured meal. The heart of this galactic emperor was not beating. It appeared to have been ripped out entirely, leaving behind a wound, a core that was not dense and bright, but strangely puffy, diffuse, and hauntingly empty. The orchestra was present, but the conductor had vanished from the podium, leaving the musicians to drift in slow, confused, and ever-expanding orbits. The silence from the core of A2261 BCG was deafening, a profound and disturbing anomaly that challenged our most fundamental assumptions about how galaxies live and die. The search began with the unblinking eye of the Hubble Space Telescope. Suspended in the void above Earth's distorting atmosphere, Hubble peered deep into the core of A2261 BCG, its mission to map the distribution of stars at the galaxy's very center. Astronomers expected to resolve that telltale stellar cusp, the sharp increase in stellar density that would betray the hiding place of the central monster. The images that returned were of breathtaking clarity, revealing a sea of ancient, golden stars, a swarm of suns so dense that they appeared as a continuous, glowing haze. But the expected feature was absent. Instead of a sharp, bright point, Hubble revealed a core that was perplexingly flat. The density of stars, rather than rising to a peak, plateaued and then fell off. The center was not a point, but a vast, hollowed-out region nearly 10,000 light-years across. The stars in this region were not moving as they should. Their orbital velocity suggested they were responding to a massive object, yet that object was nowhere to be found. They were like planets orbiting a vanished star, held in place only by the lingering memory of its immense gravity, their orbit slowly and inevitably degrading, expanding outward to fill the void. This puffy, distended core was a scar. It was the clear aftermath of a cataclysmic event, a piece of astrophysical forensics that told a story of immense violence. The scientists were baffled. They re-examined the data, recalibrated their models, and considered every possibility. Could dust be obscuring the core? Observations in infrared light, which penetrates dust, showed the same emptiness. Could the black hole simply be dormant, starved of fuel and therefore dark? Perhaps, but that wouldn't explain the missing stellar cusp. The very structure of the core had been rearranged. The evidence was irrefutable, the gravitational anchor that should have been holding the galaxy's heart together was either gone, or it was hiding in a way we had never before witnessed. The mystery deepened, transforming from a simple observational puzzle into a profound cosmological conundrum. With the visual evidence from Hubble pointing to an unprecedented anomaly, the investigation expanded. The search for a supermassive black hole is not limited to the light of the stars it commands, it is also a hunt for the high-energy death screams of the matter it consumes. To this end, humanity turned its gaze toward the invisible universe, employing the Chandra X-ray Observatory. Chandra is a sentinel designed to detect the most violent and energetic processes in the cosmos, and the accretion disk of a multi-billion solar mass black hole should have been a blazing bonfire in its field of view. As gas and dust spiral into a black hole, friction and gravitational shear heat the material to temperatures exceeding millions of degrees, causing it to emit a torrent of high-energy X-rays. This is the black hole's most unambiguous signature, the irrefutable proof of its active presence. Chandra stared at the core of A2261 BCG for hours, accumulating photons from across 27 billion light-years, searching for that telltale glow. The result was an almost perfect darkness. There was no central X-ray source. The buffet of interstellar gas that permeates the galaxy cluster, which should have been pouring into the central black hole and lighting it up, was seemingly flowing into an empty space. The search area was expanded. If the black hole wasn't at the exact center, perhaps it had been displaced slightly. Chandra scanned a wider region, looking for any off-center flicker of high-energy light that might betray a wandering monster. Again, nothing. Next, the Carl G. Jansky Very Large Array, a continent-spanning collection of radio dishes in the New Mexico desert, was brought to bear. Many supermassive black holes, especially the largest ones, are known to launch colossal jets of relativistic particles from their poles. These jets, powered by twisted magnetic fields, plow through the intergalactic medium and shine brightly in radio waves. The VLA listened intently for this radio whisper. The silence was absolute. The galaxy was radio quiet. The phantom had left no trace across the spectrum. It was not merely hiding, it had seemingly vanished without a whisper, defying every expectation and leaving astronomers with a chilling realization: they were not just looking for a misplaced object, but grappling with a process of cosmic violence so extreme it could erase the very heart of a galaxy. Faced with this profound absence, a radical and violent hypothesis began to take shape, born from the cutting edge of computational astrophysics and the nascent science of gravitational waves. This theory proposed that the black hole wasn't simply dormant or hidden. It had been ejected. It had been physically thrown out of the center of its own galaxy by the most powerful force imaginable. The story begins, as it so often does in the life of a brightest cluster galaxy, with a merger. Not just a merger of two galaxies, but a merger of their central supermassive black holes. Imagine two colossal galaxies, each with a gravitational heart weighing billions of suns, locked in a decaying orbit. For millions of years, they dance a death spiral, their stellar bodies interpenetrating, tidal forces tearing streams of stars from each other in a chaotic, luminous ballet. Deep within this maelstrom of gas and stars, the two supermassive black holes, once the undisputed rulers of their own domains, begin to feel each other's presence. They shed orbital energy by flinging away nearby stars, sinking inexorably toward one another. The final moments of this process are unimaginably violent. The two singularities, 2 points of infinite density, merge into a single, larger black hole. In this instant, the very fabric of space-time is convulsed. The merger releases a staggering amount of energy, not as light or heat, but as gravitational waves, ripples in the geometry of the universe itself, propagating outward at the speed of light. And herein lies the key. If the merger is perfectly symmetrical, if the two black holes have equal mass and opposite spins, the gravitational waves are emitted uniformly in all directions. But the universe is rarely so neat. If the merger is asymmetrical, with unequal masses or misaligned spins, the gravitational waves are radiated preferentially in one direction. And just as a rocket expels fuel to generate thrust, this anisotropic emission of gravitational energy produces a recoil. The newly formed, larger black hole receives a kick. This gravitational wave kick is not a gentle nudge. It is a force of truly biblical proportions, an event that unleashes more power in a fraction of a second than all the stars in the visible universe combined. It is the physical manifestation of Einstein's E=mc², converting a fraction of the black hole's mass directly into the kinetic energy of space-time distortion. The resulting thrust can be immense, capable of accelerating an object weighing 10 billion times the mass of our Sun to velocities of thousands of kilometers per second, millions of miles per hour. This is more than enough to achieve escape velocity, not just from the galactic core, but from the host galaxy itself. The theory posits that this is precisely what happened in the heart of a 2261 BCG. A recent, asymmetrical merger of two gargantuan black holes created a new, even larger entity, which was immediately and violently catapulted out of its gravitational throne room. It became a rogue, a wanderer, a phantom cannonball of pure gravity screaming silently through the stellar fields of its own former kingdom. It would be the ultimate stealth object, completely dark, emitting no light, detectable only through its ferocious gravitational pull on anything unfortunate enough to cross its path. The puffy, evacuated core of a 2261 BCG is the smoking gun for this cosmic hit-and-run. With the central anchor suddenly and violently removed, the tightly packed stars in the core were released from their frantic orbits. Their collective gravitational potential energy was converted into kinetic energy, causing the entire stellar population to expand outward, relaxing into the diffuse, flattened distribution we observe today. the core is a wound that has not yet healed, a ghostly imprint of the departed monarch, a stark memorial to an act of violence so profound it could unmer the very center of a galaxy. The hunt for this phantom is one of the most challenging observational quests in modern astronomy. Searching for a recoiling supermassive black hole is like looking for a needle in a haystack the size of a galaxy, where the needle is invisible and emits no sound. Yet, astronomers are tenacious, and they have devised clever strategies to track down the fugitive. A rogue black hole, even a dark one, would not travel alone. Its immense gravity would inevitably capture a retinue of stars, dragging a small, hypercompact star cluster along with it as it flies through the galaxy. This small clump of stars, moving at an improbably high velocity relative to the surrounding stellar sea, would be a key indicator. Hubble and now the James Webb Space Telescope are meticulously scanning the regions around the core of A2261 BCG, looking for just such a fast-moving, unusually dense knot of starlight. Another potential clue lies in the gas that permeates the galaxy. As the rogue black hole plows through the interstellar medium at millions of miles per hour, it should create a shock wave, a cosmic bow shock similar to the one created by a supersonic jet. This shock wave would heat the gas, causing it to glow faintly in X-ray and radio frequencies. So far, extensive searches with Chandra and the VLA have revealed no such signature. Furthermore, there is the subtle effect of gravitational lensing. As the black hole passes in front of a background star or galaxy, its gravity would bend the light from the more distant object, momentarily brightening or distorting it. Detecting such a fleeting microlensing event from an object within the galaxy itself is a task of Herculean difficulty, requiring continuous monitoring of millions of stars in the hope of catching a 1 in a billion alignment. Several promising candidate objects, small, bright knots of light and gas, have been identified over the years. Each one has sparked a flurry of excitement and follow-up observations, but to date, all have been ruled out. They have turned out to be background galaxies or other coincidental alignments. The phantom remains at large, its trail cold, leaving us with a beautiful, unsolved mystery and a galaxy with a gaping hole where its heart should be. While the recoiling black hole hypothesis remains the most compelling explanation for the strange state of A2261 BCG, science demands the consideration of all possibilities, no matter how exotic. One alternative idea is that the black hole is still there but is in a state of extreme dormancy, a condition sometimes called starvation. In this scenario, the merger event was so efficient at scouring the galactic core of gas and dust that the central black hole has been deprived of fuel for millions of years. Without an accretion disk, it would emit no X-rays or radio waves. This, however, does not fully account for the most crucial piece of evidence, the enormous, diffuse stellar core. A dormant black hole would still exert its gravitational influence, and we should still see a dense cusp of stars orbiting it. The very structure of the galaxy's heart has been fundamentally altered in a way that simple starvation cannot explain. Another, more complex scenario involves a three-body interaction. It is possible that before the two largest black holes could merge, a third, smaller supermassive black hole from another consumed galaxy entered the fray. In the chaotic gravitational dance that followed, one of the black holes could have been ejected through a gravitational slingshot effect, while the other two were flung in different directions or merged. This could potentially explain the ejection, but it requires a more complex and perhaps less probable sequence of events. The most radical, and least likely, possibility is that a central supermassive black hole never formed at all. Perhaps the merger process in this specific galaxy was so uniquely violent and chaotic that it repeatedly ejected the black hole seeds before they had a chance to grow to supermassive proportions. This would make A2261 BCG a true cosmic anomaly, a failure in the grand assembly line of galaxy formation. Whatever the truth may be, the implications are profound. The mystery of Abell 2261 suggests that the universe is more dynamic and violent than we imagined. It tells us that the bond between a galaxy and its central black hole is not unbreakable. These gravitational hearts can be torn out and cast adrift, becoming dark wanderers in the intergalactic void, silent agents of chaos destined to roam the dark for eternity. The great cosmic ocean is deep, and our view of it is still that from the shallowest of shores. The story of Abell 2261 is a stark reminder of this truth. It is a ghost story written in the language of gravity and starlight, a tale of a throne without a king, a kingdom without a heart. We have journeyed 27 billion years into the past to gaze upon a galactic metropolis, a swirling city of suns forged in the fires of countless mergers. We expected to find at its center a ruler of immense power, a supermassive black hole holding court amidst a brilliant accretion disk. Instead, we found a wound, a vast, empty core where the stars drift in lonely, distended orbits, evidence of a violence so extreme it could eject an object of 10 billion solar masses from its home. The leading theory, that of a recoiling black hole kicked by a blast of gravitational waves, presents an image of almost unimaginable power, a testament to the universe's capacity for creation and destruction on the grandest of scales. Yet, despite our most diligent searching, the phantom remains elusive, its existence inferred only by the hole it left behind. The mystery of Abell 2261 is not a failure of our science, but a triumph of our curiosity. It pushes the boundaries of our understanding, forcing us to confront the fact that the cosmos is not always the neat, orderly place our models suggest. It is wild, chaotic, and filled with phenomena that challenge our deepest intuitions. An absence can be as powerful a discovery as a presence. The empty core of this distant galaxy teaches us that even the most massive structures in the universe are not eternal, that their very hearts can be ripped out and flung into the void. It is a lesson in humility, a whisper from the deep dark that there is always more to learn, always another mystery waiting just beyond the edge of our sight. Imagine, for a moment, standing on a planet within that distant galaxy, looking up at a sky filled with a billion suns. What would you have done if you could witness it? The silent, invisible passage of a dark god, a phantom of pure gravity, as it blazed a trail of gravitational chaos through the heavens, forever changing the destiny of your home.